So welcome to this session. I'm Parag Srivastav, Senior Solution Architect, AWS, and I have my colleague Dave Bianco here, Senior Geospatial Architect. Well, what we are going to talk about is a geospatial domain which we don't discuss very frequently, but it affects us in our daily lives. Where we live, where we work, what kind of stores are near us, what kind of products and services do those stores keep, where should we bring the next hospital in that neighborhood, or where are the ambulances stationed when they're idle? It's all about the site suitability for any kind of resources that you have. Now, going back to my example of the employee satisfaction that we had, what we did was analyze the addresses of our employees at the office location, figured out what was the geocoordinates of where our employees were living, looked at the drive time and drive distances, and we were shocked to find that about 60% of them were commuting more than 1 hour each way. So 2 hours of their day gone in just commute. So what we'll do in this session is we'll focus on how Amazon Location Service and other AWS services can help us do this analysis and try to figure out what is the most suitable location for whatever your business needs are. So we were able to, fortunately, use GIS skill set, which we had within the company, but that's not possible for everybody, right? We have office locations, which is a very simple example. You have a few locations and employees to work on. But when you look at retail, for example, you have the customer-facing side of retail, and there's the operation side of retail, which is involving the employees and your logistics and operations and warehouses. So basically, there are various aspects which are involved in properly selecting a site for the best use of your business. Now, what we are going to do is we are going to look at 3 aspects. One is how can we improve the engagement with our customers based on the best site suitability that we can provide them. We have to look beyond addresses. So basically, address plus the intelligence that we get out of that address is what's going to be critical to us. We also have to look at our employees and our workforce. How do we recruit them? How do we retain them? How do we keep their satisfaction up to the level that we want? So we have to look at what their commutes are, what kind of demographics we need when we are looking at the recruitment drives, right? Where should we go and look for new employees? And lastly, how do we use Amazon Location Service and other AWS services to create solutions which provide you a good ROI for your business? Location, location, location. Everybody says that location is extremely important, right? And locations are one of the critical factors which affect the success of your business. But location is not the only thing which affects it, so we are not going to go into other aspects. You're looking at operational efficiencies and increasing revenue based on locations. We leave out the other factors which affect your site suitability. We are going to look at where the technology can help us with a better selection of the sites. So what we want is better access for customers. Nobody wants to get stuck in those traffic jams when they're coming out of a mall. Or looking at the commute for our workforces. What are the drive times and drive distances that they are involved with when they're commuting to work and going back from work? Or whether for your business, you need access to other facilities, whether it could be closeness to a highway, because that's how you move your goods, or closer to an airport, because the cargo terminal is of extreme importance in your business operations. Or when you are in manufacturing, you want to be close to the business partners that you have, which are supplying you the parts, or the customers who are consuming your output. Now, there is complexity and limitations on these geospatial solutions. Geospatial solutions, as you probably know, involve large amount of data sets. Data sets you are going to have in-house, or you would be procuring from outside, mostly procuring from outside. There's a smaller number of sets that you'll have in-house. But high quality of that data is going to be of extreme importance to you, whether it is the demographic data on what kind of employees you want to recruit, what kind of attributes you're looking for when you're doing the marketing for new recruitment drives, or the market analysis data that you have procured from outside, or the topography data, if that's what is applicable for your business. Integrity and consistency of these data sets are extremely important, because what's going to happen is you're going to procure these data sets from various vendors. They may not be in the same format. They may have different refresh cycles. You may have to do ETLs when you're consuming that data set. And these data sets may not be free. Now, how do you manage licensing for these data sets? How many data sets do you need to look at? And how many vendors you are integrating with to ingest these data sets? Also, what we have seen is typically businesses would start small with an initiative, and when it becomes successful, they want to grow. And as you want to grow into the global data sets, they become exorbitantly expensive very soon. Integrating with vendors is another challenge that you'll come across, because now every vendor will have credentials, they have their refresh cycles, they have their formats. Now you're managing the integration with these vendors rather than focusing on the outcome of what your business is. So these things just add up to the complexity and limitations of what you're doing. And then the skill set. Well, the thing is, site suitability analysis is not something that businesses will do day in, day out. It's an occasional use case. You're going to use it when you are doing creating new sites. And once you're done for many months, you may not use it. So it is occasional use of technology, occasional use of skill set. So what you end up doing sometimes is outsource the solution implementation to other vendors. And what that does, it forces you into creating point-in-time solutions. So you outsource that product, the project, it's implemented, comes back to you. Now you don't have the skill set or the technology, so you don't have the option to iterate over the functionality and improve it as time goes on. Now the biggest challenge when you look at all these factors is if you cannot do all these things yourself, then you end up with affecting your ROI and often compromising and going with non-geospatial solutions. And that's something where we typically don't want to go, right? One thing that comes to mind is I was looking at a use case for an ERP system where the requirement was to relocate employees to different locations. And the only functionality that the ERP system had was it could compute the distance between 2 points mathematically. And as you can imagine, the system was not aware of roads and highways and rivers and bridges across those rivers. So the output that it was giving to the employees where they were getting relocated, the satisfaction was very, very low.
So site selection, also known as a suitability analysis, is not a new idea. It's been around since before the advent of computers. In fact, there's examples from the US government dating back to the 1940s. But with today's powers of spatial compute, we can bring a more rigorous analytical approach to the solution. So let's overview some of the concepts and terminology that defines the site selection process. Typically, we start with a defined geographic area. This is also known as a catchment area. And there are several different ways to approach this. The most menial is to simply do a radial distance. This is taking a distance of X kilometers around a known point. And you're just blindly drawing a circle around a known point, and that is the area that will determine the starting point for your site selection. Another option would be to use drive distance, also known as ISO distance. This polygon is created from figuring out how far from a single point a distance is to drive or walk or bicycle, et cetera. So if it's 15 kilometers, that's the resulting polygon. A third approach here is drive time or isochrone. And in this case, we're using time as our measurement instead of distance. So how far would it be to drive 15 minutes or bike or walk, et cetera? As you'll notice, radial distance is not the geospatial approach. It doesn't take into consideration things like rivers and bridges that can affect commute times, that can affect access from certain neighborhoods to your site. And so the isochrone and iso distance are the preferred approaches when establishing methods with a routing approach. So additionally, we can use pre-existing data, physical and political boundaries such as land use classification, city and county boundaries, zip codes, zoning areas, can also be part of our how we define our selection area before we start the site selection process. Another aspect of site selection process is called weighted analysis. As you'll see, we'll be going through a lot of different data sets, and we might, some of the variables we might want to be comparing average household income versus the age demographic. And in one use case, we might want to favor the household income. In another use case, we might want to favor the age demographic for where we want to put our site. And so we use weighted analysis to do that. And there's several different methodologies to take that approach, whether it be addition or multiplication. You can also use binary logic and fuzzy analytic approaches. So applying these concepts, we can start to build our site selection process. The number one approach that we do with site selection is almost always a new location. And so you have a new area that you want to be a part of, and the site selection process is utilized to establish yourself in a new location. But we can also explore something called a twin location. A twin location, for example, if you have a very successful store in Los Angeles, and you want the same success for your store in New York, you can take the variables that exist for the Los Angeles location, the neighborhood that you cater to, the traffic patterns, the larger city zoning process, and find a location in New York that parallels that so that you can duplicate your success with your original location. And site selection can also help with the process of sales forecasting by running data science models against various and contrasting scenarios. So let's dive into data. This is kind of the crux of it. This is the quality of the data will determine the confidence level of our resulting analysis. Almost always we'll start with demographics. This is typically the primary source of data. Demographics, at least in the US, is collected by the US Census, and these are variables, aggregated measurements of the local population. So this includes data about age groups, like if a certain neighborhood is predominantly 30 to 40 or 60 to 70. It includes other variables like average household income. What is the percentage of owners versus renters? The education level of the neighborhood, and many more attributes are available in the demographic data. And this helps us determine the purchasing power and the purchasing interest of these neighborhoods. Non-quantifiable data, this is I guess static data that you can think of, like the locations of our competition or the locations of retail anchors, whales that we might want to be associated with, that we have a symbiotic business relationship with. Or even fuzzy terms about how a neighborhood is defined as trendy or boutique. Market analysis data is often provided by a third party, and this can be an invaluable addition to our data set collection. Live real-time data can also be an invaluable collection. Traffic and weather patterns are the most obvious examples, and these can help dictate, obviously, the historical and the themes around them, whether it's traffic during certain daytimes or weather during certain seasons can help dictate what makes a good site better as opposed to a different site. Land use classification is very important for the zoning areas to know if a certain area is commercial, residential, or industrial. And topographic and natural hazard data can also come into play here. We might take elevation data, soil type data, earthquake data, and flood data, and combine those to say this area is more suitable than that area as part of the site selection process. So as a quick aside, I want to talk a bit about one of the data formats in the geospatial realm called raster. Raster data is it's a uniform pixel size, not any different than when you take a picture with your cell phone comprised of pixels, except in this case the pixels represent data values such as the age groups or the average income, etc. And so raster data is a continuous data set as opposed to a discrete data set such as vector, which is the point, line, and polygon geometry of roads and rivers and parks. And with the lineup of data that I just went through, by combining these into raster formats and start layering them on top of each other, we can do complex spatial analysis. And this is how we can start to build heat maps by doing the weighted analysis and the analysis of the different data sets and drilling down on specific areas of pixels to then build a heat map.
Okay, so what are our solution requirements when we start building the whole environment for site suitability analysis? We want to get to an output like this where we can have a heat map figuring it out in terms of what our stores are and whether they're optimized in terms of their locations or not. The key thing to start with is address data. Good addresses will lead to a good output for your analysis. But what is good is really important to understand, right? So you may have address data which is in-house for you, or the address data which you have procured from outside. The first step that you do is to geocode the address to figure out where on the map this address belongs. Now, one of the most common mistakes that people do is to mix between address geocoding and address validation. It's important for you to understand that they're not the same thing. A geocoder has a different purpose in life. Address validator has a very different purpose in life. Geocoder will give you an approximate location. If it cannot determine the exact location, it will do various things. It will clean up your address. It will parse it. It will try to standardize it. It will break up the address components. But if it cannot find the exact match, it will give you something approximate. If it cannot understand the details, it will give you something approximate. And that approximation will give you an approximation in your output. But when you do address validation, it will say, OK, whether this address exists or not, is it correct or not? And if there are mistakes in the address, how to fix it? So we have to understand whether address validation is what you need to do first before you start doing geocoding, or your address data quality is already there when you can start geocoding at a good level of confidence. Now, if that's the particular problem that you're stuck with, where your addresses are not a good quality and you want to figure out how to do it, so we have sessions, one at 4:45 this afternoon and another one on Wednesday, where we'll dive deeper into that particular domain. But key thing for us to understand in this session is the quality of your address data is extremely important. And then, as Dave was mentioning, all this analysis starts with the demographic data, whether it is public or fee-based or a combination, whether you have this data in-house or you are procuring this data from outside. The key thing is to understand that all these data sets must align properly. You would often find that you're procuring this data from multiple vendors. The projections are not same. The boundaries are not aligning. Or the overlaps are there and it's not completely fitting together. So what's important is to understand when you're building up a solution, you have to keep these things in mind, that you may have to do ETL. You may have to do geographic operations on that data to make it usable for you. And then finally, the geospatial operations that you're going to do on this data. Because what you'll do is you'll have multiple layers of data. How do you combine them together? How do you intersect them? How do you figure out what is near to what? What is the percentage of overlap between these various layers of geographic data? And that's how your whole solution will come up. But before we start going into how the services can be used, let me give you a refresher about Amazon Location Service if you haven't already started using it. So Amazon Location Service provides 5 key functionalities: maps, places, routing, tracking, and geofencing. Now, routing and places is what is going to be key here, because that's how we geocode the addresses. That's how we reverse geocode addresses. That's how we find the drive time and drive distances between points. Maps for visualization, definitely, because when you are doing the analysis, visual aspect is extremely important, especially when you're trying to present your analysis output to everybody else. People are visual absorbers of information. So when you can put it on the map, put it in the visual format, the information will definitely be better absorbed by the audience. What Amazon Location Service provides is, first of all, it gives you the ability to integrate this geospatial data set into your application without bothering about the data itself, right? So when you want to geocode your addresses, when you want to find drive time and drive distances, there's many data sets which you need to have in your environment and the logic that you build to process them. With Amazon Location Service, you get access to that functionality so that you can focus on your business outcomes rather than building the infrastructure required to geocode and do drive time, drive distances. It also allows you to integrate with other AWS services. So whether you are hosting your data in an AWS database or whether you are doing other functionality with AWS services, you can integrate them together. When you're doing compute, you want to do a Lambda function. How do you integrate Lambda function with Amazon Location Service? That's all provided out of the box. Now, the key thing is, and this is one of the concerns that we have heard from our customers, is when you are making calls to these services, what happens to the data? Do you lose control over this data? So what happens with Amazon Location Services, we use data providers for these functionalities for places and routing, but when the call goes to those providers, your identity is anonymized. So yes, your input goes there, but they do not know who you are when it's being called. So that anonymization helps protect your privacy of your data. Other data sets which are not required to be given to other data providers, they remain in your account. And lastly, you want to build solutions and focus on the ROI, right? So how do you make the solution cost effective? By making sure that the functionality that is undifferentiated for you, that can be handled by AWS. And that can be handled by our data providers, because now they can focus on that data, you can focus on your functionality. So at this point, we have here and Esri as two data providers. More could be coming up in future. But essentially, when you are building solutions using Amazon Location Service, you don't have to manage credentials for these vendors. You don't have to integrate with the vendors directly. You are dealing with one set of APIs with Amazon Location Service. You can switch between providers just by changing your configuration. And then you get access to global coverage. So you'll start small, but you want to scale out to the global data set. Both these providers will provide you access to the global data. And you only pay for what you're using. So when you're starting small or when you're experimenting, you are only paying for what you're using in these functionalities rather than building up the entire infrastructure just to start with the proof of concept.
So let's start looking at a high-level architecture and review some of the AWS services that we can utilize for our site selection process. We'll start with data storage. The key thing here is to choose a data storage system that's geospatially enabled. This gives us geospatial functions that can help us determine area and distance. It can help us determine if a point is inside a polygon or if two polygons overlap. And we can achieve these geospatial functions by using data storage such as Amazon Redshift, Amazon RDS, or S3 with Athena. All of these data storage systems include these geospatial functionalities. They also include other geospatial unique standards such as spatial indexes and perhaps dealing with projections if that's something you need to do with your data. With compute and data processing, we can use our usual options of Lambda, AWS Batch, EC2, Fargate with Docker containers. And then we can combine those with step functions or a managed airflow as part of a process for how we want to do our data analysis at scale in production. And lastly, as Parag had just mentioned, we'll be utilizing Amazon Location Service. We can use this for geocoding addresses when we want to take the text string 123 Main Street and convert it into a lat-long coordinate point. That's the geocode process. We can also calculate drive time and drive distance through the routing API. And we can do this not just for vehicles, but also for walking and biking. And lastly, When we finalize our data process and we want to visualize the data, we can build a web app using Amazon Location Service.
So let's build a solution architecture for site suitability analysis. Again, going back to what we start with, list of addresses. Whether it is addresses of your stores, warehouses, other locations that you're dealing with, business partners, customers. So assume you have this data set in a Redshift database, and you just have a list of addresses in a tabular format. The first step that you're doing is geocoding them. Now, integration with other services is spread out of the box. So what you do is you write a Lambda UDF inside Redshift, which allows you to invoke a Lambda function from Redshift within the Redshift's environment, and Redshift managing the whole interaction with Lambda. And that Lambda function allows you to call an API for Amazon Location Service for geocoding addresses. It uses something called a place index. And using that place index, and you can configure whether you want to use Esri or here as your provider for place index, and it allows you to geocode your addresses. Now, what you have in your addresses, and when you're doing the site suitability analysis, you have a list of potential sites that you're looking for. So what you would do is you would take the candidate sites, you would calculate the distance, whether it's a drive time or drive distance, between that potential site and all the other addresses that you're interested in. Now, when you make a call to Amazon Location Service, it'll give you drive time and drive distance both back in the same call. What we advise is using drive distances where it's a static analysis that you are doing, right? So when you do not know what time of the day you're going to be making that drive. But what you can do is the time as well is what we use for my organization when we knew that people were coming to work during those morning commute hours or going back during the evening hours. So we were able to use more accurate data rather than static drive distance data to get more accurate analysis that we are doing. And the same you would apply to your business case, whether drive time or drive distance, whichever is more suitable for you. Now, you would iterate it for every potential site that you're looking for. You'll also integrate with other data sets, the demographic data that you have, all within Amazon Redshift. And since it's a geospatial capable database, you'll be able to perform geospatial operations on them and create the output that you're looking for as your site analysis output. You will be able to do this with multiple sites. You'll have multiple reports to compare, and then you figure out which site is more suitable for your needs. Now, this architecture has multiple moving parts, which will not go into the detail. But what we'll definitely do is do some demo and show you how all these things work. So what I have in Redshift here is location of my stores. And this is the data that I maintain in-house. So as you can see, my data is very well structured. I have the address line, municipality, state, and postal code very well structured in my data. But what you may have is the customer data that you procure from outside. And this data may not be as structured. So it is coming as one field, not very neat and clean in format. And you do not know whether this data is good enough for you to geocode or not. So what we're going to do is we're going to write a Lambda UDF function inside Redshift, which allows you to make a call to the Lambda function. And that Lambda function is geocode addresses for Redshift here. When you make that call, what happens is, let's run this sample data set here. So as you can see, we had the input addresses. It geocoded the addresses. And now the addresses are in a standardized format. They have been well formatted. Whatever duplicate address components we had have been removed. Things have been standardized in terms of street direction and those kind of things. And it also gives you a relevance score in terms of how accurate was the geocoding for this input that you provided. You may come across environments or sample addresses that you have where the relevance score is low. And that's a good indication for you that you need to take a look at this data from an address validation perspective, not only from a geocoding perspective. But the output that you get is the latitude and longitude. Now you know where this address belongs on the map. So you've taken a tabular data, converted into a geospatial data. Now, once you know the location, remember we were saying that we just don't want to be dealing with addresses. We want to now enrich this data. We want to add intelligence to this data. So these are the steps that we can do once you have geocoded addresses. So what we are going to do is I have stores and I have the customers. I'm going to do a brute force here to figure out how many stores are near how many customers, and I'm going to put some limits. I want all of them within 50 miles, and I'm going to use this spatial operation here called, which calculates a spherical distance. So this is just a mathematical calculation using point A and point B. This is not where we want to go, but this is the first starting point, how you start cleaning up your data and reducing your data sets. So what we have done is, I'm going to look at the data, which is these points within 50 miles between the customer and the store, and I'm going to take the top locations only. What I get in the output is customer ID, store ID. This is the customer, and this is a store. What is this spherical distance that I have computed, and what's the rank, which is the closest in terms of rank 1, 2, and 3. Now, the next step is now that you have reduced your data set to the 3 closest stores for every customer, is to now go into calculating the drive time and drive distances. We bring in a Lambda UDF again. This one is going to now calculate your drive time and drive distances. So once you do the right calculation, what you're doing here is you're making the call from within SQL, so without leaving your comfort zone of SQL within your database. You're making this call, you're giving the latitude, longitude of your store and the customer, and you're computing what is the drive time and the drive distance. The output that you get, as you see here, is the customer and the store. We have the spherical distance and the distance rank, which was computed earlier, but now we have added the drive time and the drive distance. And now you can choose which one do you want to rank on, whether you want to rank on the drive time or the drive distance based on what your use case is. So let's dive a bit deeper into finding the closest location out of these top 3 that we selected, and also looking at how different is the spherical distance versus the drive distance. So I'm just doing some more compute here, and which is going to give me what is the closest store now in terms of the drivable store, and how much off was I in terms of the distance calculation from spherical distance versus the drive distance. So I'm going to take the sample data for a particular state and compute it. So what's happening is it is making a call to location service. It is computing the drive time, drive distance, and now it is coming back with a rank associated with the drive times now, not just the spherical distance, the drive distance, not the spherical distance. And as you can see, there are a few records here in this particular case where the distance ranking and the drive distance ranking don't match. And that's precisely where you want to go. So you're improving the customer experience because now you're looking at the data which makes more sense to the customer. A drive distance or a drive time is what they will actually experience. Radial distance or spherical distance is something not achievable for them. So once you have computed this, so now you have the customer and the nearest store, but if you flip around and start analyzing the stores now, how many customers find this particular store as their nearest store? You have this data available to you now. This is your step to get to a heat map for every store in your environment that you have. And now you know how many customers consider that particular store to be their closest store, right? So you have taken your list of addresses that you had for stores and customers, and you have been now able to get to a data set where you can create heat maps now. What next can we do? After the heat map, all staying within the environment of our databases, now what we want to do is define some more geometries out of it. So what I'm going to do is, using a Redshift operation, I'm going to create sort of a rubber band shapes around these customers. So I have a store, and I have a list of customers who are considering my store to be the closest store. I'm going to create a rubber band around them, and I define the polygon which represents that shape. Why is that polygon required or important? Is now I can figure out if I want to do a marketing campaign, if I want to reach out to more customers, I know that this geographical area is of relevance to me because that's where my closest customers are, right? So once you compute that particular operation, what you have done now is you've defined a geometry, and the polygon represents the sphere of not the sphere of influence, but that area of influence around that particular store. So how about let's look at this data from a visual aspect. So I'm going to use QGIS here, using an open source tool just to visualize it. You can do the same thing using Amazon Location Service with the map visualization as well. So what we have is a map with, I have the customers. Okay, these are my customer points. I have my stores. But remember, I was computing the difference between the spherical distance and drive distance. How far was it? How much of a difference was it? Look at the points here. The red points represent more than 50% difference between the spherical distance and the drive distance. The yellow is between 15 and 50%. And under 15, I'm thinking, OK, that might be acceptable for a customer experience. So essentially, what you are looking at is 50% of the times, you're definitely going to be off from what the actual drivable distance for that customer is, and there's something that you want to avoid. So I think that's the value that you get out of it. Now, the heat map I was talking about. So now you can take the store data, and we figured out how many customers had that particular store to be the closest. We create the heat map. With these heat maps, what you're seeing is, hey, I have some hotspots here. I have 2 stores near each other. Now, have I staffed them properly? Because both of them have good traffic coming there. Do I need to merge the 2 stores into 1 store and have my staff optimization there? Or whatever else I may want to do with these hot areas, but they're cold areas as well, right? I have a store here which doesn't get a lot of traffic. What do I want to do with it? Do I want to do some market reach out here so that I bring in more customers to the store? Or do I want to merge this store with something else? These are the kind of details that you get out of this geospatial data. And then I was talking about how do you create those rubber band shapes around them, right? So these are the polygons which you're able to create all within Redshift, not having any other technologies involved. And now within these areas, what you can do is take the demographic data that Dave was mentioning about, overlay them, and now what you have is shapes coming from demographic data, shapes coming from your actual store data, and you combine them together and figure out some more market intelligence that you want to use, right? If your store is having supplies for schools, and these polygons represent school districts, you know every school district will have their own shopping list. So now what you can do is you can put the right products in the right stores based on which school district they are belonging to, and now the students, when they come shopping before the beginning of the school year, they'll be much more satisfied with what products you have in that particular store. OK, so with that, I think you would have found it useful. Let's switch back to our presentation and look at where we land. So whatever we have discussed so far, we were looking at stores and customers and finding optimal locations. But the use cases are not just limited to office locations or retail use case. You can go into various other aspects. as I was describing, what kind of products and services do you want to keep in that particular store? You can use the same methodology, the same approach, same technology to do that. Or if you're looking at non-retail facilities, so if you have long-term care facilities that you're building up, what kind of population subset you want to serve? What kind of language skill set you might need for that particular population?
A lot of the what we talked about today was locating a new site for a site selection process, but we can also talk about a store relocation. Whether you're forced to move or have a desire to move, the process is effectively the same for relocating the site to a new location and comparing how your customers will be impacted and how your revenue would be impacted. And lastly, there's use cases where we can focus on the environmental aspect. Perhaps you have a warehouse with millions of dollars of goods that you don't want damaged from forest fires or floods or earthquakes, and so you need to take these into consideration as part of the site selection process where it becomes a central component of that use case.
Okay, so just to recap, what all we discussed. So you definitely don't want to compromise on your business use case with non-geospatial processes for your site selection. So you definitely want to use the right services which takes the burden away from you for those geospatial analysis that you want to do. You can implement cloud-native solutions for site suitability analysis using AWS, Amazon Location Service, and other AWS service, where you can geocode your addresses, you can find drive time and drive distances using Amazon Location Service. You can use Amazon Redshift, Amazon RDS, S3, Athena. The architecture that I was describing, that applies to RDS and Athena as well, if that's what your data store is. And then you can use compute from Lambda in order to compute all this functionality. And basically, you can do the spatial queries, you can do the spatial operations, manage your spatial data set, all within the AWS services that we are providing for you. Now, key takeaway for you is don't just go by the statement that, hey, somebody from AWS was saying that drive distance is better than spherical distance. Go back in your environment, run that analysis, use Amazon Location Service, do that comparison, and figure out whether going with drive time and drive distance really makes sense for you. So with that, we thank you.
Thank you, everybody. We're at time. Thanks for attending.
Thank you, everyone.